function can be considered as a process also. There is an input set, inputs, and then there's a certain process happening here, process, and then there's a set of output. This in the domain of the function, and this is called the output set is called the range of the function. In other words, domain is the set of values that x can take. Domain is the set of values x can take, or independent variable can take, right, or the starting set of the function, right. And range is the set of y values, or else you can say set of output, right. Now when there is a function, how are we going to find the domain and the range of this function? Let's see some examples. So if we have fx equals x plus 3, the domain of this function, or the set of x values, right, we can take anything for x, anything belongs to R could be taken, any real number could be taken. Therefore the domain of this function is x belongs to R. We will take another example. If you have gx is equal to 2 minus 3x, here also x can take any real value, there's no restriction here, right, there's no problem. Therefore we can observe this function and say our domain is x belongs to R. We will take a little bit of a different example. Say if hx is equal to 1 over x, here if you give the value 0 here, right, dividing by 0 is not defined in mathematics, nobody knows what it is, we do not talk about it, right. So at any time, at any function, in any function, the denominator cannot be 0, the denominator cannot be 0. Therefore if we are to define this as a function, we have to say this domain is x belongs to R. If we stop here, this will not become a function, it is wrong then. And x is not equal to 0, x cannot be equal to 0. If x equals to 0, we do not know what is hx, right. Therefore this particular value has no corresponding value in the range, therefore it is not a function. But if you exclude it, exclude this x equals 0 value from this domain, then it will become a function, right. So the domain of this function is 1 over x, right, is x belongs to R and x is not equal to 0. I will give you 2-3 other similar examples, then you will be able to understand it better. So for example, if you have fx is equal to 1 over x minus 1, then we have to exclude some values. X belongs to R, right? You can take any real value, but when it comes to the case of x equals 1, this will be meaningless, right? If you have the x equals 1 in the domain, it doesn't have any corresponding value in the range. Therefore, it will not be a function. Therefore, we got to get rid of x equals what? We have to get rid of x equals 1. So we have to say, when we define the domain of this function, x belongs to R and x is not equal to 1, x cannot be equal to 1, right? So if you define another function, say fx is equal to 1 over x plus 3, right? Then what can you say? X belongs to R and x is not equal to minus 3. X is not equal to minus 3. If x is equal to minus 3, this will become 0. Therefore, it will not be a function. So we define x belongs to R but not equal to minus 3. So we will define another function which is similar to this. We will say fx is equal to 2 over x squared minus 4. What will happen in this case? Yeah, when you look at it, x can take all the values. So we say x belongs to R as our domain. But when you closely inspect this, there are two particular values that cannot be taken here. What are these? On the right, x equals 2 cannot be taken here, because if we apply x equals 2, it will be a negative. And not only that, it will be 0 here. Not only that, there is another value that cannot be taken. What is that? X is not equal to minus 2. So x cannot be plus or minus 2. We can write it in one shot also. X is not equal to plus or minus 2, right?